All right, this is 12.6 and 12.7. We're going to talk about standard deviation and variance in the first section. The second section is going to be about the normal distribution chart, and we're going to use that to find some values. The first thing we have to do, though, is talk about variance and standard deviation. What are they? How do we use them? Variance and standard deviation are measures of how the data is spread, so how it's distributed, and then more specifically, standard deviation tells us how far away from the mean or the average that we are. And when we're talking about mean, we're going to use this, we call this X bar. This is what we use to designate that, hey, this is the mean, this is the average of the data set. The standard deviation is the square root of the variance. Another way to look at this is the standard deviation is the variance squared. So if you just find the variance, you want to square root that to find standard deviation. If you find standard deviation, you want to square that in order to get the variance. Now we have two popular formulas that we use for standard deviation. One's called the population formula. The other one's called the sample. Out of these two, we are going to be using the sample one every single time because we're going to be looking at a small sample of data and we don't know the entire population. So sample just means we're taking a very small amount and we're going to use that to analyze the data. So we're always using sample. Again, these two formulas look very complex. So what sometimes people do is they do use these and they plug numbers in here and then they add them up. So sigma means adding in this case, and you can do these by hand, but we're going to do them all on the calculator. There are two videos that I posted right above this video that tell you exactly how to find the standard deviation on the 84 and the Inspire. If you have something different than these, you're going to have to search YouTube and find something to a video that tells you how to find the standard deviation. So I would type in standard deviation and then the model of your calculator. That's exactly what I did to find these videos. And so I want you to watch these if you have not watched them already in order to and follow along with the guy in order to input data and then find the standard deviation. For the following data set, you want to input this in the list and find the standard deviation. We're going to be using the sample standard deviation on this one. This is the one that's highlighted. Once you find the standard deviation, if you want to find the variance, you simply take that number, input it in your calculator, and square it. And once you do so, you get 96.67255. And here you can actually take this and you can round this. Go ahead and make sure that you input the entire thing that your calculator gives you and then round at the end. And 4 to 5 decimal spots is always a good indication of how this data is spread. So you have the previous video to look at your calculator and figure out how to find the standard deviation. Once you find the standard deviation, you want to square it to get the variance. And what I'm going to do is I'm going to post the answers to this. So just go ahead and hit pause and go through the motions of plugging these in and finding those numbers and then check your answers. So go ahead and hit pause now, complete them, and come back. One thing to note is we do want to write down the mean as well. And you're going to see why in the next section when we use normal distribution. The mean is going to be huge. So I do want you to write down what X bar is. This is the average. This is the mean. I want you to also add that portion. So after you check problem 1, go ahead and complete B and C. Here are the answers to B. And C. If you're having difficulty with this, make sure that you do go back and watch the videos above that show exactly how to input your list and then find the standard deviation and variance. Something that we're going to look at in the next section with the normal distribution is we're going to talk about the standard deviation and how specifically it works. So basically what the basis of it is, the standard deviation tells us how far away from the mean things are. Okay, so standard deviation is 204. If we're looking at this mean and we said there's within one standard deviation, which would be 204, if we added 204 to this, we would get a certain benchmark that would say, at this cutoff, there's a certain portion that falls in between this. And that's if things are normally distributed. And you're going to see that in the next section. So it'll make a lot more sense. This is section 7, the normal distribution. And again, we're going to look at this data. And anytime you have a word problem that says it is normally distributed, you can go back to this exact diagram. So this diagram is going to be really important to you. I would encourage you to draw it on every single problem. And basically, a quick lesson of what this is this middle bar right here is your mean. So that's why it was important on the previous section that we looked at this and we said, let's identify what that mean is from our stats on the calculator. It goes right in the middle. Okay, so what this is saying, it's 0, or sometimes they write X bar down here. And then what this is saying is this is 1 standard deviation away in the positive version, and this is 2 standard deviations away. This would be 3, this would be 4. This right here is also 1 standard deviation away. It's just in the other direction. What we say is that when we say it's within 1 standard deviation, that means that it's either positive or negative. And that means that 68% fall within 1 standard deviation if it's normally distributed. What the second one says is within 2, so positive 2 or negative 2, within 2 standard deviations, 95% of the data lies here. And then within 3 standard deviations, 99% is going to fall within 3, which is the majority of our graph. There can always be little tiny pieces at the ends that tell you how far it's spread, but when it's normally distributed, these are the percentages that we're going to have to use. So we always want to come back to this, and on problems, we want to draw a rough sketch of this often. So on this question, it says it's normally distributed. Okay, so that means I'm going to just draw my normal graph, and I'm going to put the mean right in the middle. This is 21. It says the mean was 21. Standard deviation was 2. So I'm going to draw another line right here. I'm going to say if the standard deviation is 2, then that means I'm going to add 2 to 21 and get 23. That's 1 standard deviation away. And in the other direction, I'm subtracting 2, so it's 19. Here would be 17. Here would be 25. If it's asking what percent would you expect to score between 19 and 23, then we are looking at specifically the area of this portion of the graph. And if you remember from the previous, that is the same as this portion. Okay, and it stops at this line, and it stops at this line because these are both 1 standard deviation away. So we would be able to say, we believe 68% we would expect to score between these two values. Now looking at the next one, what percent would you expect to score between 23 and 25? That would be right here. That would be 1 portion of it, and looking back at the normal graph, this would be 23 and 25. We'd be looking at specifically this area, which would be 13.5%. One of the biggest things I cannot emphasize enough is the drawing of this graph. As long as you draw this normal graph correctly, and you put the values correctly in it, so you put your mean here, and then you put your values that are 1 standard deviation, 2 standard deviations away, then these problems are not difficult at all. Okay, and then the last one, what's the probability a student chosen at random is between 17 and 25? So looking back at our normal graph, in between 17 and 25 would be within 2 standard deviations of the mean. So adding these together, we would get 95. All right, the next example, it says that this is normally distributed. So draw your graph. Here is your mean. Your mean was 100,000. Okay, so obviously you probably want to take a little bit more space to write this. Mean of 100,000, and then it says standard deviation is 10,000. So this would be 110,000, obviously 120,000. If I go 10 in the other direction, okay, I would say this is 90. This is 80. This is 70. And then this would be 130. Okay, so it says about how many batteries will last between 90,000 and 110. So looking back at a larger distribution, and you're looking between 90 and 110, you can easily say that that area is 68%. Lie between those two. About how many batteries will last more than 120. So going back here, 120. If it's normally distributed, that means we're looking at the area to the right. We want more than that. We want 2% plus 0.5%. And that gives us 2.5%. How many batteries will last less than 90? Going back to it, here's our 90 bar. We want left of it, we want less, so we add these values up. 0.5 plus 13.5 is 14%, plus 2 is 16%. Then the final question says, what's the probability if you buy a car battery at random, it will last between 80,000 and 110,000? So between 80 and 110 is this area, which is represented by, we know that this is 68 plus 13.5 is 81.5%. So our biggest things are make sure that we label the mean on the normal distribution graph. Make sure that we do know that you do know those values, those percents that are represented by it, and also make sure that you are able to take two values and find and add up those percentages between the two values. So those are all big ideas. I want you to draw a rough sketch of this one, placing your values where they need to go and completing this problem. I want you to hit pause and hit resume once you have completed it, and I will walk you through it. Hit pause. Hit pause if you haven't done it. Now this is what your graph should have looked like. I added this -3, -2, -1 just to show you exactly where your value should fall. It's not 100% necessary. I would make sure that your mean is exactly in the middle so that you know exactly where to start from. And then on A, between the heights of, do the middle 95% fall. So if you remember this, the middle 95%, this was 13.5, this was 13.5. So looking at ours, our middle 95 would start here, be between these two values. So we could say that the middle 95 would be 58.6 is where it starts, and that's to 69.4, and that was inches. The second one says, what percent of young women are taller than 61.3? So 61.3 is right here. You know that this is 34, this is 34%, this is 13.5. We continue on, it's 2%, and then it's another 0.5% on the tail. So we end up adding these together and we get 84% that are taller than 63.3 inches. So we're looking at this entire area. Okay, we don't care about this other area. We're only worried about the ones that are taller than 61. The second example, very similar. If you want to complete it, and we can talk about it during ACT Lab or before and after school, I'm okay with that. Basically, you have to do the same thing. You will always want to draw that normal distribution. If it says approximately normal, something like that, then we're using that normal graph. So you can complete it if you want. I'm not going to require it. The last thing I'm going to leave you with is this. Make sure that you know these values. Make sure you know how to use it. Thank you.